Hi, in this video, I am going to discuss about the boosting machine learning algorithm. What is the boosting approach in machine learning? Boosting is an ensemble technique. It is an ensemble machine learning. Okay, it uses the technique. What it does is it combines multiple weak learners to make a strong learner. It combines multiple weak learners to create a strong learner. And training here is sequential. Training is sequential. In bagging, training is parallel, but in boosting, training is sequential. It is an ensemble machine learning approach. It combines the multiple weak learners to make a strong learner. Training is sequential. So these are the points of boosting. If I draw it, if I try to show it diagrammatically, so this is our data. Okay. So boosting will create multiple weak learners. Say this is model 1, model 2, model 3 to model n. All of these are weak learners. Weak learner. This is also a weak learner. This is also a weak learner. N number of weak learners. The boosting will combine all of these weak learners. It will combine this. It will combine all of these weak learners to make a strong learner. That means combination of these models will give you strong learners. Okay, multiple, this point is covered. It has multiple weak learners will combine to create a strong learner. And training is sequential. Training is sequential. What does this mean? The data will first be transferred to train machine learning model 1, and then after training the data will be transferred from model 1 to model 2. Data again will be transferred from model 2 to model 3 and model n3 to so on. It continues. So data after training, once the data is trained by model 1, then it is transferred. Then it is transferred to model 2. Okay. So here is the catch in boosting. When model 1 trains the data, okay, when model 1 trains the data, model 1 will train on a data set and it will make predictions. It will train on data set. It will make predictions. The predictions will be correctly predicted data, correctly predicted. Some data points it will predict correct, and some data it will make wrong predictions, that is incorrectly predicted data. So what does the model 1 does is, the model 1, it will increase the importance, it will increase the importance of wrongly classified data or incorrectly predicted data. Importance of incorrectly predicted data, and decrease decrease the importance of correctly predicted data. So model 1 trains on data set. It will train on data set. It will make prediction. After making predictions, there are two types of, obviously it will make some error. So there are incorrectly predicted data and correctly predicted data and incorrectly predicted data. For correctly predicted data, it will decrease the importance, and for incorrectly predicted data, it will increase the importance. Will increase, here it will decrease. And then this data, the new data where the correctly predicted records have decreased importance and incorrectly predicted records have increased importance, this data will be given to model 2 for training. So what does the model 2 does here? The model 2, the machine learning model 2 will focus, it will focus on incorrectly predicted data. Why? Because here there is an increase in the importance. The importance of incorrectly predicted records has increased. So model 2 will focus on incorrectly predicted records and tries to fix it. Again, the model 2 will make predictions. Model 2 will make predictions. It will also do the correctly predicted records, makes correct predictions, and also the wrong predictions. Again, it will repeat. It will repeat. Again, what happens here? Decrease the importance of incorrectly predicted records. Incorrectly predicted records. Decrease importance. And correctly predicted records. I think this should be, these are incorrectly predicted records. Incorrect. These are correct. Okay. And for, sorry for that. For incorrectly predicted records, increase the importance. And for correctly predicted records, decrease the importance. Right. So this cycle continues, and again it will give this data to model M3 for training. For training. So this is how the boosting will work. The sequence will continue. The sequence of increasing and decreasing the importance of data points, increasing and decreasing the importance of data will continue. This is the logic behind the boosting. So boosting will train in a sequential order using the weak learners. The model 1 will train on a data set, make predictions. The correctly predicted data, it will decrease the importance. For incorrectly predicted data, it will increase the importance. And it will give the increased and decreased important data to the machine learning model 2. And model 2 will focus on incorrectly predicted records. And again, it will increase or decrease the importance based on the prediction. And it will give to the model 3 for training. So this sequence of increasing and decreasing the importance of data records, predicted data records, will continue. This makes a strong learner. Makes a strong learner. What will is the use of boosting? Boosting will reduce underfitting. Reduce the underfitting. Your model is underfitting, you can go for boosting algorithms. Thank you for watching.